In June 2026, the National Oceanic and Atmospheric Administration issued a major climate advisory. Their data indicates a 65% probability that by the end of the year, the globe will enter a very strong El Niño event. This map tracks rising temperatures in the eastern Pacific alongside a positive Indian Ocean Dipole to the west. When these systems converge, their combined influence suppresses rainfall across the Indonesian archipelago, transforming a standard dry season into a severe, prolonged drought. To understand the physical threat posed by this current forecast, we have to look back to the last time these two massive oceanic conditions aligned with this much intensity: 1997. In this part of the world, a drought of this scale acts as a geographic trigger, transforming routine land use into the catalyst for disaster. Across Southeast Asia, farmers have long used fire to clear land for planting. Under normal conditions, this slash-and-burn method is a manageable agricultural tool with a limited environmental footprint. While independent farmers use this method, it is scaled up to an industrial level by massive commercial timber and plantation companies looking for the cheapest way to clear vast tracts of forestry. This entire system relies on predictable seasonal rainfall. The arrival of the wet season serves as a natural safety net, ensuring these deliberate agricultural fires are extinguished before they can spread into the surrounding wilderness. An El Niño-driven drought removes that safety net. Without the expected rains, fires set for routine clearing escape control on a massive scale, consuming thousands of square kilometers of forest. This demonstrates how standard commercial farming practices become uncontrollable regional hazards the moment the climate provides the necessary conditions for fire to spread. The geography of Southeast Asia adds a uniquely volatile element to this crisis: tropical peatlands. These are naturally waterlogged, carbon-dense layers of decaying organic matter. To make this land usable for plantations, companies often dig extensive canal networks to drain the water, leaving the organic soil dry and exposed. During a severe drought, this drained peat undergoes a physical transformation. The water table drops further, and the organic material oxidizes in cracks, turning from a fire-resistant wetland into a massive, brittle tinderbox. Once ignited, the fire moves vertically, smoldering deep through the subterranean layers of carbon. Unlike a typical forest fire, the combustion happens largely out of reach, beneath the surface. These underground fires render conventional surface-level tactics useless. Firefighters can spend weeks dousing a single area, only for the heat to persist beneath them, allowing the fire to smolder for months until the monsoon rains finally return to flood the soil. This makes peatland the ultimate crisis multiplier, upgrading a temporary surface fire into a persistent, unkillable carbon bomb. By the end of the 1997-98 dry season, the destruction was staggering. Over 9 million hectares of land have burned, and the fires released up to 2 billion tons of carbon into the atmosphere. The resulting toxic smog completely crossed borders. Neighboring nations like Malaysia and Singapore, which had not lit a single fire, found themselves suffocating under a thick gray haze that obscured entire cities. This created a public health emergency and paralyzed the regional economy. With flights grounded and tourism halted, the total economic toll reached an estimated $9 billion. The environmental crisis also collided with the 1997 Asian financial crisis. The collapse of the Indonesian currency meant the government lacked a fiscal capacity to fund a massive high-tech firefighting response. Geopolitically, the smoke fractured ASEAN diplomacy. It exposed the limitations of their non-interference doctrine, as one nation's domestic land use practices were effectively poisoning the air of its neighbors. The 1997 crisis proved that environmental catastrophes do not respect political borders, inevitably turning domestic economic priorities into international crises. Fast forward back to the present. The exact same variables, the El Niño drought, the positive IOD, and vulnerable drained peatlands are assembling once again. However, our capabilities have improved since 1997. We now have satellite fire detection systems, months of meteorological lead time, and a legally binding ASEAN treaty on transboundary haze. This lead time allows for preemptive mitigation. Authorities can focus on re-wetting programs, physically blocking those drainage canals to restore the water table and make the peat fire-resistant before the dry season peaks. There is also a clear need to move enforcement beyond smallholders, holding massive commercial operations accountable through immediate, preemptive burning bans. Advanced climate warnings and legal frameworks are only effective if they result in immediate action on the ground. If governments wait for the first spark to ignite, the sky will inevitably turn brown again.